having all that, you plug into the probability formula, and then you'll be able to calculate probability. Okay. Just review the formula, and then let's see if we're able to calculate it. Some higher level calculator also have the binomial distribution formula. In that case, you copy your NCQ calculator onto MathStack distribution of the probability. But the way you pretty much follow the fundamental formula structure.
You like the formula?
Sure. So follow the first formula if you're calculating probability. N times Q if you're calculating expectation and mean is the same thing. If you want to calculate the variance, you calculate N times Q times Q. If you want to calculate standard deviation, you calculate square root of N to Q. So what's the question will dictate what formula you're using. And also you have to know it's binomial. If it's not binomial, of course, this formula will not work. If your calculator has the PRD, which gives you ways to calculate combination, probability, combination, permutation, and factorial. If your calculator has the max and HPHP, then it might also have the binomial distribution formula in there, which could make a little bit, could also speed up your calculation.
Yeah, I do have a question. When I was calculating this, like, this is what I got, and then, like, let's say, I got something like that on the test, should I just use the question? I mean, I'm sure there won't be a question on the test with that on it, but I have to do the calculation on my phone calculator to get that.
Oh, that's 0.0016. That's the same thing, right? It's the 1/65. National definitely.
Okay. I never really knew how to
Reason? Your the calculator notation is 1.6 10 to the negative 6 power. And then to the right, you take the 1.6 and you move the decimal point 6 places to the left. If it's positive, you move to the left. If it's negative, you move to the left. So 3 places there. It was the original here. Now you have 1, 2, 3. Now the decimal place is 2. And if you have decimal place, again, you can zero before the decimal, and everywhere 6. So, see, that's one place, and you're supposed to have a 0 in here, and a 0 in here. Okay. So, basically, before the 1, you enter 1, 2, 3, 3 more 0. So, the negative 3 is going to have more 0 on the left. If you're moving to the right, that means you add a different place to move to. That's kind of how you do it.
so that helps me out.
Okay. Yes. Questions?
What is the X formula?
Oh,
What is the X's for this one?
right, X equal to 10. Oh, it's my fault. X is 10. What did I write? See, I have no idea. Yeah, that's the X. X here is the number of success. So this is a probability of having X success in any file. In the function, we have 10 success in 12 files. So 12 represents the total number 12. The 10 represents number of success out of the 12 files. So we should learn how to connect the verbal description of the question with the numerical description of the formula. So that's why I'm trying to connect the notation with the number success. Here is the probability of success. So P and X is kind of match with the probability of success. X is the number success, so P to the power X. Because success has to be repeated X times, so it's like a P times P times P independent, right? Multiplication probability. That's the multiplication rule. So basically, a binomial distribution, we follow the multiplication when you have independent events. Yes? Oh, C is a combination number. So in P-L's calculation of two numbers, C is, we have C on the calculator. Mm-hmm. No. You have to search out like SEO look for many online and you might find out. Different calculators have different ways to do certain things. For this one you have to figure out how to do it. You can also calculate your P by side. The P is within the number. So in our case, let's calculate. So if we're calculating this by self, so we're really calculating P of 10. Okay. So we need to calculate 12C10 times P is 0.96. The P to the power of 10 and 0.04 to the power of 2 because you see n minus x. N minus x, 12 minus 10 is 2, so that's that number. So in this whole calculation, the first thing you have to know is 12C10. So how do we calculate 12C10? It's a combination number. We will calculate 12 factorial divided by 2 factorial and times the 10 factorial. So that's the same as our calculation. I guess that could be a problem if we're calculating this. So we're going to try to find common factor between the numerator and denominator. So what's 12 factorial? Is 12 times 11 times 10 times 9 times into the 1. So those are all together is actually 10 factorial. So 12 factorial is actually 10 times 11 times 10 factorial. I start at 10 factorial because there's already a 10 factorial in the denominator. So I see the 10 factorial as a common factor between the numerator and denominator. So we cancel the 10 factorial and the 10 factorial in the denominator. Those are a common factor. And then you end up having 12 times 11 over 2 times 1. So those calculations give you 12 times 11 is 132. And you divide that by 2, we have 66. So the first number here, that is 66. So overall, we were supposed to calculate 66 times 0.96 to the power of 10, and then times 0.04 to the power of 2. The rest is all algebra calculations using your calculator. I hope that clarifies.
questions all end up in C?
No, the C, yeah, the C is a 366. 12, C, 10 is a number.
What is
The
it?
rest is they are the binomial formula. So in the binomial formula, you have to have a C number, calculate e to the power x, e to the power n minus x. So do you know how to get out of your table? Here, question. Yeah, go back to it. Anything else? I'm going to do 11, so control 5. I need one more. Oh. Alright, so 66 is what we have for the C number, the combination number, and you also have to multiply the 0.96 to the power 10.04 to the power 2. If you're using the online calculator, it looks like this. You go 66 times 0.96 to the power of 10, and then times 0.04 to the power 2. This is okay. Thank you, calculator. I think it's to calculate everything in one step. No, it's 66. The C number is 66. But you don't have to calculate 66. This part is already 66. Yeah, so 66 times 196 is the power 10, right? And 104 is power 2. 196 to the power 10. Thank you. Any more questions? Do you have any additional comments? Yes.
So I know how like but when it says at least 3, and then it said something on the homework about like 1 minus something. I don't really understand why. Is that
1 minus p, again, that's the q, right? Because in the formula, I try to condense it. In the Newton, it actually went ncx and then p to the power x times 1 minus p to the power of n minus x. I think that's what presented on the,
yeah, they might have just
yeah.
I mean, it's all figured out.
We can try a couple examples from the assignment. We tried a few last time. The second assignment. First question is find and visualize probability using the binomial distribution. So whenever it says you visualize, it probably presented some kind of graph for us to see. Like this question, 80% teenager play video games. So the percentage is now 80%. I'll just write 0.8. We turn the percentage into decimal. Researcher takes a random sample of 22 teenagers. So the number of trials now 22 total numbers of teenagers, and survey whether they play video game. And it turns out Okay, we want to use the binomial distribution to calculate the probability exactly 19 of them play video games, so success is 19. So 19 out of 22 play video games. So those are the parameters. And then submit this, and then we're going to visualize what's going on. The number of trial is, in our question, is 22. So we remove this to 22. Success was 80%, so we move this to 80. Sometimes this is a hard time of pinpointing the right point. Make sure you have a sensitive computer to do that. And then we have x equal to 19. The x is 19. So number of success is 19. So we move this one to the number 19. And that's our answer. This is one that I have a visualizing probability chart to present. You can actually look at the chart to help you with the identify the answer, and you have to read your solution that 41775 is represented in the app. Question, that should be okay, because we're not calculating the quantity ourselves, we're applying the app. And this is a hypothetically saying, suppose the answer is 0.33, what was your interpretation? You're going to have to refer to the question. We have 22 as a total number trial. We have 19 was a success. And let's assume that the answer was 0.38. Answer. Of course, it's not. It's 17 actually, but hypothetically thinking this is how you verbalize the conclusion. This question says public buying movie tickets. So that's our P, and you buy 21 movie tickets. With this probability exactly 14 have a popcorn coupon. So that's the way you calculate with the formula, right? So let's try a few questions to see whether we see the one you mentioned. Here's the image of this. Alright, so now we have this question. First thing is you read the question, you have to realize this is a binomial question. Especially if this kind of question pops up in your final exam, one of the key issues is to identify what formula do I use. What kind of question does this question belong into our whole idea of the model, right? So we have question in the final exam as a collective review of what we do in the whole semester. So sometimes a single question may not feel as difficult when they're in a chapter exam, but when they show up in the final exam, one of the things that you identify where they belong to. So in this question, the number one thing you have to realize is a binomial distribution. Now with that, you can identify what formula we're using. This question P equal to 0.717. And we also have the total number is 21, total number of trial. And we want to find out what is probability to have 14 success. So x equal to 14. Identify those three numbers, which then allows you to apply the formula. Probability of having exercise out of n trial is NCX. And P to the power x. If we have to use the 1 minus, it's going to be 1 minus P. I was using 2, which is a lot shorter than this. So 1 minus P to the power of n minus x. That's the formula. Then we're going to look at what we need to calculate. We have to calculate 21 C 14. This is multiplied by 0.717 to the power of 14. And let's multiply by 1 minus 0.717 to the power of 21 minus 14, which is 7. That's applying the formula. And so we're going to calculate this with a calculator. This is supposed to be 21 choose 14. And that you need to find a way to handle this C number calculation. Most of the calculator does this. If you don't know how to calculate this, you can do this. I mean, even for yours, you have to look for your own manual how to calculate combination like this, and there will be a kind of like a, you can also evaluate it and probably it's kind of process. Same thing, so figure out a way to deal with the question with the resource that you already have. And your calculator is your tool and your resource. Make sure you understand how to use it. All right, so with our question, we'll calculate the whole thing. It's like, how many decimals do we need? We need 3 decimals, so the answer will be 0.160. And question. So every time you finish the computation and you see the solution, try to compare that solution with what you have. This question says a softball pitcher has 0.3 probability of doing a strike, and we show 22 pitches. What is the probability exactly 12 of them are strikes? And I think that's possibly pitches. Okay.
I understand that. Almost, you know,
Right.
what I mean?
Uh-huh.
Because it's hard to explain.
Yeah, I think it's a randomized process. Everybody gets a different question, so it's a little hard to pinpoint it. You can take a screenshot. On the keyboard, there's one that says print screen, and then if you look at the question and print the screen, and take a little picture of your question. And what I did, I used Paint. It's one of the apps that's on every computer. So you can then Control V to paste the picture in the file and then save the file and send it to me. Like, it takes 80 seconds to make the picture for your screenshot. So you can get to see your question. Any other questions? All right, so this is second assignment. First assignment, we have formula for the distribution. Remember the first formula, this is binomial, and we also have the mean formula, which is n times p, the variance formula, which is npq, q is 1 minus p. And then we also have the first assignment, which is a general distribution, again, the general discrete distribution. In that case, you have a table, and in general distribution, you end up having a table. You can also draw a table for the binomial distribution. In this case, the x will also be x is supposed to be 0, 1, 2, 3, 4, until 21. You can set up a table for all of the x values and all the probability values calculated one by one. In the general distribution, you have one column, one list for the x value, and then one list for the probability value of each x. Right, whenever you have that, you can calculate the mean by, the mean is calculated by a summation of x times probability of x, and the variance is calculated by a summation of x squared times p of x minus the mean squared. Right, that was the variance calculation. Then the standard deviation is the square root of variance. I just wanted to try to review so they kind of know what we're doing in the chapter 5. It's always a very common thing is, but for any distribution, we want to be able to calculate it, and we want to be able to calculate variance and standard deviation. But one of them is represent the center, the other one represents the deviation, the variability of the data. So it's kind of common to know those two parameters. Now, the last one we're about to go is called the Poisson distribution. Binomial distribution and Poisson distribution, they actually have something in common. Both of them are calculating probability of having a certain number of success. So, for example, P of x in Poisson distribution is calculated by, we have a little notation. It's kind of like it's a Greek letter called lambda. Pronunciation goes I have to draw it. The spelling is lambda. Right. Lambda represents a Greek letter. It's in the Greek alphabet. So lambda raised to the power x multiplied by e to the negative lambda. Remember, it has to be negative. E to the positive lambda will be really big number. So make sure you have e to the negative lambda, which is part of the quantity control. E to the negative lambda is 1 over e to the lambda. It's really a small number. So that makes sure the probability is a number that's less than 1. Remember, when it makes the probability small, you don't want the probability to be higher than 5 and 16. So make sure probability is small and divided by x factorial. That's the formula. So it looks quite different from the formula that we have for the binomial distribution. What's the connection is this probability. It represents probability of x success, which sounded very similar. Probability of x successes. Actually, we don't exactly call it success in Poisson distribution. Is the probability of having x occurrence of something. So something has occurred x times. What was probability of that? But it's similar to the binomial distribution. And the interesting thing for Poisson distribution is this little number lambda. It actually represents the mean of the distribution. Mean equal to the lambda. Lambda is the average. So for Poisson distribution, what's nice about it is that it's also equal to the lambda. What's nice about it is that you don't need a lot of things. You don't need the number trial. You don't need the success rate. Actually, the success rate is really small. And so the only thing you have to know is average how many occurrence. For example, let's say it calculated out of 20 days on average number of students I have during that office hours is 1 student. So on average each day I have 1 student. Some days I have no students coming to visit me. Sometimes I have 3. But on average 1 student per day. So that means lambda equals 1. So now if I have no other information, obviously average is pretty easy to calculate. I can just count how many days that a month. And this month, someday I have more students, someday I have less. Or I can average them out, which is 1 student on average. See, I don't have to calculate probability. I don't have to calculate percentage. All I have to calculate total number of students divided by total number of days. And then I have to average the number of students, which is lambda. And then once you have that lambda, it's like having a key information. So you're going to calculate P of 0. For Poisson distribution, P of 0 is probability of having 0 visits, or probability of have 0 success, which equals to lambda to the power 0, any number to the power 0 equal to 1. 0 factorial equal to 1, also 0 factorial also equal to 1. Lambda to the power 0 also equal to 1. So then the only thing I want to calculate is really the e. So all I have to calculate is e to the power of negative lambda. I have to draw the letter lambda. That's all there is. So if the number of students I get on average is 1 student, so the probability of having 0 visitor today, which would be e to the power of negative 1. It's about 36%. See, that's probability already. So from a known probability information, which is the average, I can calculate probability of 1, probability of 0, probability of 2, if I'm using Poisson as my distribution model. So this is assuming lambda equal to 1 now. And then e to the negative lambda is roughly 0.37, which is the probability of 0 visitor during office hours today. So Poisson distribution has, well, binomial and Poisson, they're both calculating probability have x number of successes, but in the binomial distribution, you have to know the total number pi, you have to know the success rate. For Poisson distribution, it's more relaxed. the only thing, it has to be something that doesn't happen too often. And in Poisson distribution, let's say I don't get a lot of visits, and sometimes I have no student comes by. So things are like low likelihood things, right? So, but many things in life can follow Poisson distribution model. For example, you look at an intersection on the highway, the number of accidents, it happens, but it doesn't happen very often. So let's say every year there may be two accidents on that intersection, or sometimes zero. But on average, let's assume the number of accidents is two. So now you can calculate what is the probability there are zero accidents on a certain year, what is the probability there are two accidents and one accident. So the probability model itself allows you to have a handle on how likely something might happen if all you know is the average. So it presented a way to quantify a likelihood of something if the only information we know is the average. So Poisson distribution has its position, and let's look at a couple of questions in the assignment. All right, there are a couple of other introductions for Poisson distribution, like what is Poisson distribution and how to calculate, this is the Poisson distribution formula. So you follow the formula for its computation. So if you're interested, you can also watch a few more videos just to get a deeper understanding it. And there's also a scenario about whether distribution is Poisson or not Poisson for here. Poisson distribution, since it's very, very rare, and then it's the rest of how you, if they follow a pattern, that's not Poisson. If it's have a concentration, it's not Poisson. Poisson is when things are very evenly distributed in such an interval. Okay, so let's look at the third assignment. So, kind of similar to the binomial scenario, one of the things we want to be able to identify is what was the key component of the formula, that lambda. One of the things in Poisson distribution I didn't specify, probability of success during a interval. Right. What do I mean? So suppose your average number of students for me, number of average number of students is one student per day. But if you ask me average number of students per week, it will be seven, right? Average is one student per day, so the a week, five students for a week, right? Or 4 weeks, we have 5 working days. So you can see if you expand your interval of time for interval of whatever that we're talking about, the average will go up. So you have to attach a time frame or an interval to your lambda. And that's why sometimes it's a little hard to identify the proper lambda. Make sure you really look at what's being asked in the question. Let me enlarge this. Okay, this question. So this question is like try to understand the parameter of the question. So we're focusing on the correct lambda. So here's the question. The title says we want to understand the parameter of Poisson distribution. Essentially, Poisson distribution does not have a lot of parameter. Lambda is the only thing that we need to know. Okay. Let's use the word parameter. It's a very old term. We have the word parameter in the first chapter. Parameter and statistics. Parameter is what's going on in your population. These are the keys. Statistic is what's going on in your sample. That is letter S. Okay, so Poisson distribution has only one parameter. That's the lambda. So we want to find the proper lambda for the question. So in here, the restaurant gets an average of 12 phone call in 2-hour interval. So your lambda has to be attached to the interval. So in this question, the lambda equal to 12. So on average is 12 phone call when the interval is 2 hours. 2 hours, then average number of phone call is 12. We want to find the probability that the restaurant will get exactly 2 phone calls in 30 minutes period. So now down here our interval, we'll just right, interval in here. The interval is now 30 minutes. We're assuming the distribution is distributed evenly. So if you get 12 phone calls per 2 hours, how many phone calls do you get in 30 minutes? That's the lambda we're looking for, right? Shorter time frame should have smaller average or smaller number of phone calls. So how do we go down from 2 hours to 30? That's how we have to go down from 12 to the lambda we're looking for. So we're looking for this lambda. The question asks for the lambda. We're not asking for the probability. We're not calculating probability. We're figuring out the proper lambda. The proper lambda is part of the calculation of probability. But sometimes we want to calculate probability, sometimes we don't. In this question, in order to calculate probability, what do we have for the lambda? So how many phone calls for 30 minutes? 1, 2. Yeah. 12 for 2 hours. How many for 30 minutes? 6? 3?
Oh, I was just reading off the question.
Oh, right. Oh, yeah. What is the probability of getting 2 phone calls in 30 minutes? So that phone call, the 2 phone call, that's not a lambda, that's a x. We want to calculate probability of 2, right? So the 2 is the x. But first, we have to find the proper lambda. Okay, so let's scale things down. 2 hours, 30 minutes. What was the duration? I mean, if you got 2 hours, how many minutes is the 2 hours? How many minutes in 2 hours? 120. So you multiply by 60, 2 times 60 is 120. So 120 minutes, 12 phone calls. 20 minutes, 12 phone calls. 30 minutes, how many phone calls? Definitely should be less, right? And that's the average. That's the lambda. We're trying to pair the average. Know that the meaning of lambda is the mean. So mean number of phone calls for 120 minutes, 12 phone calls for 30 minutes. That's for you. So what's the average number of phone calls? How do we go down from 120 to 30? We divide, right? We divide by 4. So you have to divide 12 also by 4. So you get 3. So here the answer should be 3, and it's also the answer 3 in the question. The answer is 3 right here. Alright, of course we should all try to understand the process of how we get here, and here are the formula that we're using. You see we paired the 120 with the 2. 12 calls per 120 minutes. Divide that phone call per 30 minutes. Just looking for that average phone call for 30 minutes. And then of course you solve this equation. How do you solve this equation? You multiply both equations. How does it amount to 30? 11 equals 12 times 30 over 120. Any questions? So let's figure out a way to handle this kind of question. And this is the first step. If you have the wrong lambda, if you ever want to calculate probability of 2, if you're using the wrong lambda, will cause you leading you to the wrong number for the probability calculation. Okay, use Poisson distribution to compute probability. Okay, so this is a question. Calculated. Alright, so now we're really looking at what is the probability. This is what is the probability that the department store will get at most 3 phone calls in 55 minutes. So let's first look at the question. What is the probability? So we're calculating a probability. What do we mean by at most 3? At most 3. At most 3. 3 and 2 and 1 and 0. 3 is the maximum, right? So x is less or equal to 3. That's the meaning of at most 3. So we're calculating this. So what is at most 3 means we gotta calculate probability of 0, which is less than 3, and then probability of 1, and then probability of 2, and then probability of 3. Those are the required calculations. And then we're going to move on to exactly how do we calculate the probability. We use the Poisson distribution function. Probability of x is equal to, and here see that formula again. Poisson distribution is actually a limit version of the binomial distribution. So you see factorial, which is called the, or inherited from the binomial distribution. So we have x factorial. We also have the power function, which is from the combination and the combination. Okay, so it's limit lambda to the power x and e to the negative lambda. So in this setting, when the x change, all those x's also change in the formula. Then you have to know the proper lambda. And again, a lambda represents the average. What is a lambda? Which is we're calculating probability of having at most 3 calls in 35 minutes. So lambda represents average number of calls in 55 minutes, because that was in the question. Okay, probability is related to 35 minutes time frame. So I'm trying to set up a table so we kind of know what would be lambda relation between the lambda and the time, number of minutes. So what do we have? We have some information about the average. It says here that you get 16 calls in 2 hours. So we have 16 calls in 2 hours, which represent 120 minutes. That's and then now we're looking at how many phone calls in 55 minutes. 55 minutes. What was the number of phone call? We have no idea. Let's label that lambda. So we're going to look at the table. When we were supposed to zero down, there should be less number of phone calls if you're looking at a small time frame, right? If the proportion of the thing down 120 to 55, what was the proportion to down, right? So sometimes we do have a hard time identifying the proper lambda in the calculation. So I would recommend set up a table using this table that we already have. Set up an equation. Then we have this. Lambda is paired with the 35. So you have lambda, which is paired with the 55. And the 16 is paired with, it's the same column as lambda, but same row as 120. So you have 120 over here. So you're going to set up the equation like this. I pulled the equation directly from the table. Make sure the same thing is in the same row, like times 55 is the same row. So this lambda and 55, same row. 16 and 120 are in the same row. 55 and 120 are in the same column. So these are in the same column. Lambda and 16 is in the same column. So make sure that your column row or line are exactly right as that question is. So the proportion is correct. Question? Alright, now next solve this to get our lambda calculated, kind of like what's being presented on Newton. A common way of solving this kind of equation is cross multiply. So we cross multiply, and then we have lambda times 120. It's equal to 55 times 16. So lambda equal to 55 times 16 over 120. Okay, what do we have here? 7.3. Is there anything after? Oh, 7.632. So let's leave it at that. So that's our lambda. So with the lambda, we can start calculating all these. We are supposed to do 4 calculations of the same format. They all follow the same format. So let's write it. So we'll go lambda to the power 0 over 0 factorial, and then e to the negative lambda, plus lambda to the power 1 over 1 factorial, e to the negative lambda. This is all algebra. Let's try to figure out a way to concise the calculation. Lambda to the power 2 over 2 factorial, and e to the negative lambda. You can see they have common factor. That's why I'm trying to present it. I didn't really copy into the lambda value because it's better just to leave it to the last step. Lambda to the power 3 over 3 factorial, e to the negative lambda. So we realize that every single calculation of these probably involves e to the negative lambda. So we're going to group those together. So we're going to group the rest of them together, move the e to the negative lambda to the outside. And then lambda to the power 0 equal to 1. 0 factorial is also 1. So 1 plus lambda, 1 factorial equal to 1, plus, this is lambda squared over 2. 2 factorial equal to 2. And then lambda cube over 3 factorial, which equal to 6. So this kind of concise the whole calculation. We know we're going to need the lambda value, but you don't want to enter the lambda too early, which probably end up getting everything messed up. So right now, if they stay pretty concise. Now let's look at the calculation. So it's going to equal to, now it's time to pop this into a calculator. So you get a calculator, you can enter the entire thing. So we go 1 plus 7 point, I'm going to leave it 3 decimals, so 333 plus 7.333 squared divided by 2, and then plus 7.333 cubed over 6. And this is everything inside the parentheses. And it's okay if you want to pop this into a calculator now, or you can just start calculating, multiply e to the power of negative lambda. So it's negative 7.333. There, now it's time to pop this into a calculator. And this is really what you enter into your calculator also. And here we are. So with the Poisson distribution calculation, we have 0.0659. How many decimal? We need 3 decimal. Maybe I should keep more decimal. Let's see if I change this. Right now is 0.666. If we increase the decimal, I realize that 3 is supposed to be repeated. So it be more accurate. That doesn't really change much. So we'll take the solution 0.066. So here we are. We have 0.066. That's the 3 decimal solution. So here we have. That's the entire calculation. I hope that kind of helps you out with the when you have to calculate probability. Well, some probability with multiple x values. In this question, we don't just have one x value. We actually have 4 different x values. We have 0, 1, 2, 3. Anyway, we look realize that's a lot to calculate. But Poisson distribution does not need a combination number, so instead we can calculate with what we have on the English calculator. Well, pretty sure we say a better way to present it. At 7.33, but the same thing as 23. Do you have any questions? Alright, the question asks for 3 decimals, so in the intermediate solution we have 4 decimals. That doesn't mean the number equal to the 4 decimal number, it just means with 4 decimals accurate enough. That question. Alright, this is a similar scenario. What is the probability that more than 4 trains will pass the house in 4-hour period? Let's do one more practice question. Hopefully this gives us sufficient practice how to calculate Poisson probability. Next question. All right. Ruth has noticed 19 trains pass by her house on the nearby train track. So that's for 24 hours. What is the probability that more than 4 trains will pass her house at in a 4-hour period? So that's the question. Let's try to label the question. So we're going to find probability more than 4. How do we present more than 4? Bigger than 4? Right? So we're trying to find probability x is bigger than 4. So we're going to verbalize what's more than 4. Now we're explain this way. So if it says more than 4, you cannot have both sides. You cannot have 6 plus 1, right? It must be 1 by 1. So when you mean what do you mean by probability of more than 4, we have to calculate the probability of 5. 5 is more than 4. 5 train pass by. Or probability of 6. Or probability of 7. And then we realize that the term more than it doesn't stop anywhere, right? So that's the problem. So what do? We calculate the opposite. So calculating all the calculations, finish all the calculations for all more than 4 is going to be impossible. So we don't do that. So what was the other part of more than 4? Which is less or equal to 4, right? So we could calculate probability x is less or equal to 4. Less or equal to 4, which is the opposite. If you calculate the opposite, and then 1 minus the opposite will be your answer, right? So what we're going to calculate is, move this a little bit to the side. So we're going to calculate 1 minus this, which is exactly how you deal with its opposite. You find out the probability of less than 4, but that's not the answer. That's the opposite of the answer. So you do 1 minus what you have there. Move this. Right, so that's what we're gonna do. The less or equal to 4 is slightly easier, but not by a lot. So 1 minus less than 4, such as probability of 0, is less than 4, and then probability of 1, and then probability we have to go 0, 1, 2, 3, 4, 2, and probability of 3, and then probability of 4. Then we stop. So 1 minus all of that. That's probability of more than 4. That's basically the plan. If you ask how to calculate individual probability, you follow the Poisson formula. And in the Poisson formula, we know that we have to have a probability of x is calculated by lambda to the power of x over x factorial e to the negative lambda. So the formula is not long, but the formula calls for a number, lambda. And we have to know in this question the proper lambda. If you're talking for a 24-hour, you have 19. But if you're talking about 4-hour, we don't know the average. We know that was for x, right? That's not the lambda. So we're gonna set up a table similar to what we did. The lambda we're looking for is the lambda for 4 hours. The lambda we have right now is for 24 hours. So for 24 hours, we have 19. Right? For the 4 hours, I have no idea what it is. So we're going to start calculating this. All right, let's do the cross multiplication, cross and divide. 4 times 19 divided by 24. Anybody have a lambda calculated? So what's your lambda? So 3.16. Thank you. So then we have our lambda, so we're going to start looking at the actual calculation. Lambda is part of the process of our calculation, so it's 1 minus. We do the same process we had earlier. P of 0, so this is our formula. You can apply 0 for your x. So that's the 0. This is 0. All the x's is now 0. So the calculation is going to be lambda to the power 0 over 0 factorial e to the negative lambda minus lambda to the power 1, and then 1 factorial e to the negative lambda. Okay, repeat the same process. Hopefully, after repeat so many times, you start realizing that you already memorized the formula for the Poisson distribution. So lambda to the power of 3 over 3 factorial e to the negative lambda. And the last one, lambda to the power of 4, and then 4 factorial e to the negative lambda. So that's a pretty lengthy process, but we can still do the same thing that we had earlier. You can do 1 minus, we can factor a common factor, which is e to the negative lambda. In that, inside the parentheses, we have a lambda to the power of 0, which is 1. So it's 1 plus lambda squared over 2 plus lambda cubed over 3 factorial, which is 6, plus lambda to the power of 4 over 4 factorial, that's 24. That's all it is. And there's the underlying factorial that's going out. This is over 1 times 2, 2 times 6, 6 times 4, and then all the numbers should have an entire thing there. Are you okay so far? So now we're going to apply the lambda. We're going to really pop this into the calculation. Before all these are algebra, I just want to make sure the equation was a little bit more concise. You understand what I'm saying? And that's why I didn't calculate individual P of 0, P of 1, P of 2. I actually expanded the formula for P of 1, P of 2, P of 3, P of 4. So once you expand the formula, you realize every one of them has e to the negative lambda. So we don't have to get e to the negative lambda combined these two each individual calculation. We just pull it outside and do the calculation outside. The purpose of this really is trying to make the calculation shorter. So 1 minus parenthesis 1 plus 3.166 plus 3.1666 squared over 6, and then plus, I guess I could copy and paste. That could make this process so much faster. Okay, so this is raised to the power of 3 over 6. The same thing, raised to the power of 4. This is over 24. Now let's finish everything inside the factoring of the power term. And e to the power of negative 146. It's the entire calculation. We need to enter this into our calculator. Oh, it should be 2. Yes, thank you. Alright, so I think, thank you. That's supposed to be 2. Thank you. But once we have everything entered, we how many decimals do we need? We need 3 decimals. If it's 3 decimal, we have 0.213. That should be the solution. I hope that clarifies how we try to find a way to get around things. Because you know, it's a pretty lengthy process, right? So I try to do a little bit algebra just to help out with the combination of the calculation. So the answer is 2.1.213. That's the calculation down here. You have, it's similar to what we did, but this process requires you have every one of these calculated. I don't want to enter 5 times the same thing into the calculator. You understand? This calculator, you have to do this, copy to the calculator, get that. Copy this into the calculator, get that, and then so it's more time consuming to have individually calculated. So what I'm hoping is to find a way to have all of them into one single calculation. So I will pop that big thing into the calculator and do it one time for it. There's also ways for you to double check your calculation. I did mention last time, or like halfway, 38%. I mentioned last time that we got a calculator for the Poisson distribution. On the test, you don't get to use the online calculator, but when you're doing your homework, it is always worthwhile to find a way to double check your work before you submit it. You can go online to the online resource. It has a few Poisson calculator in here. One of them is this. I guess you have to put a little princess here. We can use the one with the little app. Should be similar to this one. It's similar to the binomial distribution, but this is the Poisson distribution inside here. That was the name of the distribution. This is the parameter. We started naming different distribution now. We have binomial distribution, which is the BINO, it's BINOM. That's what it's named in a couple of online calculators. Or your handheld calculator also have names for the binomial distribution and Poisson distribution. Like the one we just did, this question we can double check. So we have lambda is 3.1666. So you enter 3.1666 repeated. We have the x, which is the boundary value. X is 4. We have x is bigger than 4. So here we got 4. We want x to be bigger than 4, which means bigger or equal to 5. Right. And then I guess if you have equal sign, this will start with 5. And that's what we have. So the answer will be 0.213. 0.213. That's kind of like what we did. 0.21345. And we have solution from that. So we're adding this one with this one with that one. You can also confirm all these quantities where you are calculating all these one by one with you. If you want. Any questions? Right. I hope the app kind of help you with speed up your process of calculation. If you finish all 3 assignments, chapter 5, Poisson distribution, binomial distribution, and general distribution, we're going to move on to the next chapter. We're going to talk about continuous distribution next time. So far, do you have any questions? All right, if you see any student in our class, remind them that I have a student that was not here today. I have all the classes recorded online. I started recording the classes to, you see this under content, you scroll down to class recording inside Classroom Ultra. This is really where I started the recording app. Inside the menu, there's recording. So these are a couple classes that we recorded in the past. Last week I recorded 2 sessions. It looks okay. I mean, try to name them so you know what was going on at that time. That way, if you accidentally miss a class, the recording will kind of keep you updated, like what we did. And I hope that will help out both the class and the student in the class and student not in class today. All right. That's it. Just want to announce that it gets there, so from now on, if you miss any class, you can still have a way to look at what was going on in class. All right, that should be it for today. I hope that you guys try to finish it and send me your image of that question so I can send you back with the solutions. Thank you. That's it for today. Thank you.